This is Geometry, Section 2.5, Reasoning in Algebra and Geometry. So, today we start what are called proofs. Proofs are a big part of geometry. So to start off, we've got some properties. So, first properties are addition, subtraction, multiplication, and division property of equality. Basically, all those are saying is if I add something to one side of an equation, I have to add it to the other side. If I subtract something from one side of an equation, I have to subtract it from the other side. Same thing for multiplication and division. Those are common properties that we use in algebra. These four are more specific to geometry. So the first is the reflexive property. Reflexive property basically says A equals A, or something equals itself. Seems silly right now, but it's going to come in handy a lot in the future. The symmetric property also seems a little bit silly. It says if A equals B, then B equals A. We're not going to use this one that often. We'll use the reflexive property a lot. This one doesn't come in that often, but it will come in. So the next one is the transitive property. Transitive property is sort of like the law of syllogism that we learned in the last section. So transitive property says if A equals B and B equals C, then A equals C. The last one, substitution, this one is going to come in a lot. So if A equals B, then I can substitute B for A in any expression or equation. So, a proof. Proof is a way of explaining your thinking on the left. So we write a proof as two columns, as we see down here. So on the left, we put our statements, and on the right, we put our reasons for that statement. So the first statement that we write is always what we are given. We're always going to be given something. So here my first statement is going to be 5x minus 20 equals 2x plus 7. And I'm trying to prove that x equals 9. So that's always going to be my last step. I'm going to put that as my last step. So my reason for my first step is that I was given that information. So I just write given. Next, we figure out, okay, what would I do? What would the next step be for me to solve this equation? Well, I could add 20 to both sides. So if I do that, I would end up with 5x equals 2x plus 27. So the reason from this step to this step would be the addition property of equality that I talked about up above. I added one thing to one side, so I had to add the same thing to the other side. The next step, I'd want to get all my x's on one side, so I'm going to subtract 2x from both sides. I end up with 3x equals 27, and that was the subtraction property of equality, because I subtracted something from both sides. Next would be to divide by 3. So my fourth statement would be x equals 9, which is our last statement because that's what we were trying to prove. So the reason would be division property, because I divided by something on both sides. Alright, so fill in the reasons for the given steps. This is sort of like a proof. These are our statements. These are our reasons. So again, our first reason is always given. So we are given that AB is 50. The next statement says AC plus CB equals AB. Well, AC is this, CB is this, AB is the whole thing. That's going back to the first chapter that we did. That was called the segment addition postulate. When I add two pieces of a segment together to get the whole thing, they equal the whole thing. So that's the segment addition postulate. Next, I went from here to here. Well, if I look at my diagram, it tells me that AC equals 2x minus 2, and CB equals 4x plus 1, and I was given that AB is 50. So what I'm doing here is I'm just substituting those values in for these segments or these lengths. So this is substitution, because I'm substituting those values in. Substitution. Next, what happened? Only thing that changed is I went from this to this. So that is the distributive property, which hopefully you know that from algebra as well. Next, I went from 2x plus 4x to 6x, and negative 2 plus 4 to 2. That's just combining like terms. So I combined like terms. Next, I moved the 2 over to the other side by subtracting it. So that's subtraction property. Subtraction. Finally, I divided by 6 to get my answer, so that's the division property. And that's it. Couple more proofs just to know what we're talking about. So now, in terms of geometry, what does this mean? So this diagram I've got over here, it's given to me that angle 2 is congruent to angle 5. So I'm going to mark that on my diagram with a little angle mark, a little rainbow mark. So we were given that information. I'm trying to prove that angle 1 is congruent to angle 9. So what else do I have here? Well, I've got angle 1 and angle 5 make an x. So we remember those are called vertical angles, and those are congruent to each other. So angle 1 would be congruent to angle 5. Similarly, angle 2 is also congruent to angle 9 because those are also vertical angles. Those make an x. So I can write those on the same statement because those are the same thing, the same reason. So these are both vertical angles. Next, we're trying to prove that angle 1 is congruent to angle 9. Well, I've got all these pairs of angles are congruent up here. So I've got 1 is congruent to 5, and 2 is also congruent to 5. Well, if 1 and 2 are both congruent to 5, 1 and 2 must be congruent to each other. That's an example of the transitive property that we talked about on the first page. So 1 and 2 are both congruent to 5, 2 congruent to 5, 5 congruent to 1, therefore 1 is congruent to 2. Similarly, if 1 is congruent to 2, 2 is also congruent to 9. Therefore 1 must be congruent to 9, which is what I'm trying to prove. That is also just another example of the transitive property. So, last one, we're given that f is the midpoint of EG. F is the midpoint of EG. So, if F is the midpoint of EG, then these two pieces, EF and FG, must be congruent to each other. Similarly, G is the midpoint of FH. So if G is the midpoint of FH, then GH must be congruent to FG. So those are congruent to each other. So how do we write this out in a proof? We're trying to prove that EF is congruent to GH. So first statement, F is midpoint of EG. G is midpoint of FH. Reason given. Second, so like we said, EF must be congruent to FG, since F is the midpoint. So the reason is because it's a midpoint. F is a midpoint. Same thing as that. We've got FG congruent to GH, because it tells us G is the midpoint of FH. So those two segments are congruent to each other. So now we're trying to prove EF is congruent to GH. Well, EF was congruent to FG, and FG was congruent to GH. So this is another example of the transitive property. Since EF is congruent to FG, FG congruent to GH, these two things must be congruent to each other. EF congruent to GH. Alright, last proof. So we are given that AB is the bisector of angle CAD. So we're given that this is a bisector, which means these two angles must be congruent to each other. We know that. And we're trying to prove x equals 9. So based on everything that we know, we've got to write a proof. So we are given this, given that AB is the bisector. Therefore, since AB is the bisector, angle CAB, if we look at our diagram, CA, this is A right here, CAB must be congruent to angle BAD, because a bisector cuts the angle in half, creates two congruent pieces. So this is because we have an angle bisector. We've got two equal pieces. Since the angles are congruent, the measures of the angles are, this should say, equal to each other, because congruent angles have equal measures. This statement is really not that necessary, but you might see it written in sometimes. So now that we know these two things are equal to each other or congruent to each other, we can substitute the values that the diagram gives us. So it gives us that angle CAB is 7x plus 2 and angle BAD is 5x plus 4. So we're just going to substitute those in there. So this is just substitution. Then all we're doing from here to here is distributing the 5. That's the distributive property. Then from here to here, where do we go? So we could subtract the 5x. And on the left side, we would have 2x plus 2 equals 20. That would be subtraction property. Then we would need to subtract the 2 from both sides. So that would again be subtraction. So if we subtract the 2, we've got 2x equals 18. Our last step would be to divide by 2. And we would get what we're trying to prove, x equals 9. So last step, statement 8, reason 8 would be division.